Hi everybody, it's Miss Austin. I'm going to be going through the lesson today, which is about finding angles with sides that are passing through points. So yesterday we put angles in the coordinate plane, talked about coterminal angles. Today we're going to find angles when we know a specific point. Let's get to it. Suppose the terminal side, so where it ends of an angle in standard position, passes through the point -7,4. Find a possible measure for this angle. Possible because we know from today that there's an infinite number of coterminal angles. So let's go plot that point. So it's like -7,4. I'm just ballparking, right? And the angle passes through here, through this point. It wants me to find this angle right here. All right, well, I can drop this down and create a triangle, right triangle, and I know this is -7 and this is 4. And now I can't find this angle right here directly, but I could find this angle right here using trig. I'm going to zoom in. So I have this right triangle with an opposite and an adjacent side. Now the part you need to be careful with is the calculator. The calculator only spits out answers for trig functions for the values for which it is defined, which we haven't gotten into a lot. So the best way to do this is to not acknowledge the negative when you're finding the angle. Okay? So what I would actually do is maybe just even remove it. So here you have this triangle. It's got a 7/4. Okay, yes, it's over in quadrant 3 or 2, so the 7 is negative, but that's okay. So I want to find this angle. I've got opposite and adjacent, which is tangent. The tangent of some angle is 4/7. I'm going to go to my calculator. Inverse tan of 4 divided by 7, and it spits out about 30 degrees. Now that's not the answer. That is 30 degrees right there, right? This angle is 30 degrees. We're in quadrant 2, and it wanted this angle that ended there. So if this is 30, right, all the way to here is 180. So if that's 30, that leaves 150 left for this angle they wanted me to find. So the answer is 150 degrees. Now that's just one possible angle, right? You could add 360. You could do, what would this be? 90, 60. We could go negative. So that would be 210, -210. They just want any angle whose terminal side ends here. Again, the best bet with the calculator, because I'll show you what the calculator would have spit out if I would have left it negative. Second tan 4 divided by -7. It spits out a -30, which is actually down here, which is the same as that up there. Again, it's because the calculator only gives the answers for which tangent is defined, and we haven't really looked at the graph of tangent yet. So the best bet is to take the triangle, ignore the negatives, find the angle, go back and look at what it means in the quadrant you have. Okay, let's try another one. So the answer, possible angle, 150. B, find a possible measure for an angle in standard position whose terminal side goes through the point 18, -23. So I've got 18, -23, something like that. So I have an angle that goes all the way around and then just going through that point right there. Right? -18, or sorry, +18, 23. 18, -23. So I'm going to make a triangle out of that. You always make your triangles down to the x-axis, not over here. Right? This is 18, and this is a -23. Now, I can't find this angle right here, but I can find this angle right here that it makes with the origin. If you go to your calculator, you type the negative in. In this particular case, it will spit out the right answer because tangent is defined in this quadrant. So to avoid errors, I'm just going to keep promoting removing the triangle, thinking of it as just a triangle where you don't have any negative distances, right? I've got opposite and I've got adjacent. So I've got the tangent of I don't know is 23 over 18. Tangent 23 divided by 18. So it's about 52 degrees. Now that's not the answer. It's 52 right here. So because it's in quadrant 4, you could use 52, but it's negative 52. If I wanted to do the positive angle, right, it's all the way around except 52 degrees. So this is a possibility of 308 degrees. For this, right? If I did the negative one, it actually would be negative 52. The only reason I bring that up is because in this particular case, if you typed it into the calculator, second tan, and you did negative 23 divided by 18, it would tell you the answer is negative 52, which is one of the possible answers. That wouldn't have worked on this one. Remember when we did it here, it gave us negative 30. That's because it's giving us this right here, which is the same triangle over here. Then we have to know where we are and that it's actually 150. Okay? So again, how many answers are there? There's an infinite number of answers. This one, the negative 52, a little bit more visible, and 308 is if I was going around counterclockwise. Okay? All right, last one. Consider an angle in standard position whose terminal side contains the point negative 12, negative 5. So negative 12, negative 5. So some angle negative 12, negative 5. Now, again, I create this triangle. I can't find that entire angle, but I can find this angle right here. So this is my negative 12, and this is my negative 5. So I'm going to blow this up, and I'm going to ignore the negatives. This is 12, this is 5. Theta is always the angle made with the origin, and you always drop the triangle down to the x-axis. Okay? So now I've got opposite and adjacent. Tangent of some angle is 5 over 12. Second tan 5 divided by 12, about 23 degrees. Now that's not the answer. This itself right here is 23 degrees. So my angle is starting here and going all the way to here and then there, right? Right? This is 180 plus that extra 23. So 180 plus the 23, 203 degrees. That's one possible answer. Or if this is 23 here, right? But this is 23, then what's this chunk right here? Well, that would be 90 minus 23. This makes 67. So if I wanted to figure out the negative angle, which you don't have to, but it would be negative 90 plus 67 more. So that would be negative 157 this way. So either 203 or, again, you could do negative 157. Now let's just see, if you didn't ignore the negatives, what would the calculator give you? I want to just show you, it gets a little confusing. So let's pretend we'll leave the negatives on both. So we'll go second tan, negative 12 divided by negative 5. Oops, I did that backwards, sorry. Second tan, negative 5 divided by negative 12. And it, again, see how it spits out 23? But it's not 23 degrees. It's giving the triangle that was over here that was the same. But we have to know what quadrant we're in. We're over here. Okay, so the best case scenario, plot your point, create a triangle, drop that point down to the x-axis wherever you are. You always make your triangles to the x-axis, right? And then remove the triangle, ignoring all negatives. Figure out what that angle is, go back and plop it in and think through the problem. And you can give the positive angle, you can give the negative angle, you can give any possible angle you want that has a terminal side there, any coterminal angle. I hope that helps, and I'll see you guys soon. Bye.